Okay, welcome back, third year. And you might remember last period we were looking at distance, speed, and time. We had a look at the formula for average speed and how that is equal to the distance travelled divided by the time taken to travel that distance. We looked at this experiment where we had a simple setup of a trolley rolling past two markers, measuring the distance with a meter second of time with a stop clock. And we decided that this may not be accurate due to issues with reaction time. If you have a ruler at home and somebody willing to help you, you can actually measure your reaction time. You simply place your arm on the desk and you would have somebody drop the ruler between your fingers. They do not tell you when they're going to drop it, and you have to measure the time it takes for that distance of ruler to fall through your fingers. And you can use the formula velocity equals distance over time and work out your reaction time. If you're interested, you can click play on this video. The video is also in your Firefly blog, and let us know and we can work out who is the quickest in the class. So back to today. We have completed our worked examples and you should have completed the questions on average speed. We're moving on to a slightly different topic today, and that is the topic of instantaneous speed. Now, we're familiar with average speed, as in our speed over a whole distance. Okay, imagine you are driving from Glasgow to Edinburgh. You may take an hour, and you know that it is 40 miles to Edinburgh. So you would say, therefore, that your average speed is your distance divided by your time. If the units were miles per hour, that would be 40 miles per hour. Our notes here have an example of Glasgow to Dundee, a distance of 80 miles, and they travel in 2 hours. So distance divided by time, 80 divided by 2, tells you their average speed is 40 miles per hour. However, we know that when you're on the road, you may come to roundabouts, corners, you may be on the motorway. Instantaneous speed is a way of measuring your speed at a specific instant. It is very much a clue in the name. If you were driving along the motorway and to look over at the speedometer, whatever value you see on the speedometer would be your instantaneous speed. It is a tricky quantity to calculate accurately. The actual speed of a particular instant, as it says in the notes, is difficult to measure, but can be estimated by finding the average speed over a very short time interval. The shorter the time interval, the nearer the estimate will be to the instantaneous speed. So we have a slightly different setup here. The instantaneous speed of an object can be estimated by measuring the average speed over a short period of time. And this can be done using a light gate connected to an electronic timer. So I will try and find a picture of this arrangement to put into the Firefly blog just so you can see what it would look like in school. We have a trolley which is going to roll through the light gate. The light gate removes the human error. It removes the reaction time. It's a computer system which will stop and start the clock. The light gate will measure the time it takes for the length of card, the distance, to go through the light beam. And this is explained below. The timer starts when the card on the trolley breaks the light beam and stops when the card leaves the light beam. The time recorded in the timer is taken for the card to pass through the beam. The width of the card is measured with a ruler. So instead of measuring the time it takes to pass between 2 points, we are now measuring how long it takes for that section of the trolley to go through the light gate, giving us a much more accurate estimate of the instantaneous speed. Instantaneous speed, width of card divided by time and timer, would be the formula you use for this experiment. As it says though, this does measure the average speed of the vehicle the card passes through the light beam. The narrower the card, the closer the measure of speed will be to the instantaneous speed. So if we had a card which was 1 centimeter in width, then that would be a lot more accurate than this card, let's say, which we could give as 5 centimeters in width. We're trying to find the velocity of the point where the mass of the car goes through the light beam. The smaller we make that card, the closer to the true speed of the trolley we can actually calculate. The width of the card must be measured very accurately. Let's choose the right pen. And the timing device must be capable of measuring small time intervals. So if it was to go into milliseconds, that would be much more useful. There is an experiment here which we will have a look at during this period or next period. What we're going to do just now is go through the question booklet. We hopefully have completed these questions and been able to discuss them on a Teams call. What we're going to do is have a look at instantaneous speed questions. The formula, speed equals distance over time, is what you need. So I'd write that at the top of the page to keep yourself correct. Problem 1 is very much looking at the experiment, reading the details that are given to you, and problem solving to find the answers. So how the average speed of the trolley down the ramp could be measured. We would look back and think we've got our start line, our finish line, and we've got a stop clock. So it's calling upon the information that we learned in the last period. We then have a graph of speed against time, asking us to find the car's instantaneous speed at various time intervals. To find its speed at 10 seconds, you would go across to 10, find out where that is on the speed axis, and you would be able to tell that the car is traveling at 4 meters per second, for example. So what we're going to do just now is have a little go at these questions 1 to 4. I will be on the Teams call for you to come in and ask for help, and we will discuss as a class any issues that arise. And after this, we'll have a look at the experiment. So if you were to go to Firefly now or to OneNote, you can open up the booklets and have a look at these questions. Thanks.